All right, moving on to interfaces and discussing why we call them a contract. In object-oriented programming, an interface is a truly powerful architectural tool. It specifies what a class must do without dictating how it actually does it. Think of a legal contract or an agreement between two different parties. If a class agrees to implement an interface, it formally signs that contract. It promises the compiler that it will provide concrete code for every declared method. Let us look at the top part of the code on your screen together. Line by line, on the very first line, we write public interface shape. Notice we use the keyword interface here instead of the keyword class. An interface is entirely abstract by default, meaning you cannot instantiate it directly. We declare double area open parenthesis, close parenthesis, followed by a semicolon. Look at the code comments next to it. Contract only, no method body, there are no curly braces, and there is no implementation code here. We are only defining the method signature, establishing the formal rule for any geometric shape in our program. Now, let us move down to the next block of code, where we create our circle class. On this line, we write public class circle implements shape. That keyword implements is the formal declaration where circle signs the contract. Circle promises to fulfill every single requirement defined in that interface. Inside the class body on the next line, we declare a private member variable called private double radius. This variable represents the internal state, specifically to calculate properties of a circle. Next, we see the constructor for our circle class. On this line, we write public circle open parentheses double R close parentheses. Notice that the parameter name is declared as R. Inside the constructor body on the next line, we write radius equals R. Because the parameter name R is distinct from our member variable radius, we do not need the keyword this here. Directly assigns the incoming value R straight to our private field radius. It properly sets up our circle object in memory before any calculations take place. Below the constructor, look at how circle fulfills its contractual obligation. On this line, we write public double area, open parenthesis, close parenthesis, matching the signature in our shape interface exactly. Inside the method body on the next line, we write return math.pi times radius times radius. This is where the abstract contract of a shape becomes a concrete calculation. Another class, like rectangle, could implement shape and calculate area using width times height. The interface defines the common expectation, while each specific class provides its own unique implementation. Take a look at how clean and modular this structure is. By separating the interface definition from the class implementation, we achieve loose coupling. The interface specifies the expected behavior, while the circle class encapsulates the concrete formula. Always remember that any class implementing an interface must provide the complete implementation for all its methods. This exact architectural design is fundamental to writing clean, maintainable software. In fact, this is precisely the pattern we will use throughout this entire course for every abstract data type. You will soon see interfaces like stack ADT, queue ADT, and map ADT. You might notice letters like T or K and V inside angle brackets next to those names. Do not worry about those generic type parameters just yet, as we will introduce generics in detail in an upcoming module. For now, simply remember that an interface defines the contract and our concrete classes implement the underlying data structure. Take a moment to review these concepts, and we will see you in the next lesson.